Now we have come to the main topic which we'll be discussing on model context protocol and how the MCP solves the M into N problem. So let's look at this image. On the left you can see a laptop with three different cables plugged in. One for charging, one for display and one for the HDMI. This is a kind of an old way of doing things, having to use multiple ports for different tasks. But then, if you look at the right side of the image, you will see how things change with MCP. Instead of using multiple ports for each cable, MCP lets you use just one port to handle everything charging, displaying, and even connecting USB devices. Why does this matter? Well, with just a single port, your device becomes a lot more efficient. No more worrying about which cable goes where or dealing with cluttered workspace. Plus, it saves time by allowing faster connections and better data management. This is exactly what MCP does. It makes sure all these tasks happen smoothly through just one connection, simplifying the whole process. In short, MCP is super useful because it keeps things neat, efficient, and more powerful. That's why we are seeing it more and more in modern devices. And I will demonstrate you a simple example without MCP first, and then I will explain you with MCP how this M into N problem gets resolved. Okay, let's first understand how the user, application, LLM, and the tools interact with each other. So when the user asks this question, what is the weather in Paris, to our application? So this time, this is our own application. This is not a Google AI Studio or a Chat GPT, but this is our own application where application takes the input from the user and it should have defined a function declaration, the list of functions. It should have been declared so that it is available to the LLM. So in the previous slides, we have seen the inbuilt tools where LLM uses the inbuilt tools to fetch the weather. So how does it work? So LLM uh, interacts with the Vertex AI, that is the Google Vertex AI, the orchestrator, where it already has all the inbuilt APIs. So the tools directly calls the Vertex AI. Vertex AI calls the API, and then sends the results back to the user or the application. But in this case, these are the custom functions which an application defines itself. Okay, then so you can just I have put the example here where the get weather function, like get weather parameters, the string description, name of the city, and then the get air quality check. So these are the two functions which we have defined in our applications, so that LLM knows about these tools. Because how does the LLM is not, basically the LLM is not aware about all your custom tools. It needs to be uh, embedded in your query while you are sending this to the LLM, so that LLM takes the user query and also the function schema means the structure. Both the application would be sending it to LLM, then LLM, based on the user's query, it will check or it will select the appropriate function schema and then sends back it to the application. So the model, in this case, the model processes the user input. Model determines the appropriate function. So today, just an example, we have get weather and get air quality, but in real time applications we might have 50 tools or 50 functions or hundreds of functions, and all you have to send it to the LLM, because LLM is just a memory, and it's not aware about what custom tools you have defined. So you have to send this every time when along with the user query. Okay, and based on the function schema, the LLM will identify which appropriate function would actually fetch the correct results. So model determines the appropriate function. Model would have decided which function to call, then prepares the necessary parameters, and then it sends back to the application. and calls that function. So here is one important aspect is LLM will only send the structured request, but it will never executes the function. So that control is still with the application. So function, so it calls that function executes the appropriate APIs and returns the output to the LLM. So here we have a more control. Under the function, you can call any of the API, whether you can call Google search to fetch the result, or you can directly call the weather.com or weather APIs, other weather APIs. That is a choice of the application on which API you have decided to call. And then once it is executed, the result will be sent back to the model. Then the model formats and sends the response back to the application, and in turn the application will send this to the user. Now I will explain this with a simple example. So if you can see here, we have defined this application has a function definition. As you can see, it takes the city as the parameter and then exit. So here I have used a mock data, but in this place you can call any of the API, like I mentioned before, weather.com or any other weather related APIs you can call. But here I have put a mock data. Okay, this is a function definition. So you have defined a definition, or yeah, you have defined the function in the application. Next comes, so I have two function definitions. One is to get weather, and then the air quality check. Then these are the function schema. Function schema is like it will tell the LLM or to any other application for when it has to execute this function, what are the parameters which are required. So in this case, say for example, in this case, for get weather, city is one of the parameter. So the schema should be like what is the function name, its description, and the parameters and the properties which it needs to get to respond with the correct result. So in this case it's city. So for example, if I give Paris as the city, then it will return the correct temperature. Okay, so these are the schema. So if you now see here, so there is a application sends the input to the LLM. So now we have put forth this question, and then it has a function declaration or a function definition. Now we have to send this information. So application sends the input LLM along with the function schema. In this step, it combines the weather plus this two function schema. Let's see this again. So these are the function schema. So now if you see, this is the system instructions, and now this is a user question. What's the weather like in Paris? So the first step is application to the LLM. So this is how you actually trigger a message from the application to LLM, where you give the to what model you want to use the messages. The message is nothing but this one, the user message. And then as part of the tools, you are including all the function schema. If you see here, you are including this function schema. And then based on the response you receive from LLM to application, now it LLM makes a function calling. So it has understood the question of the user, and then it decided. So if you see here, so model determines the appropriate function, model decided which function to call. Now it is making a function call to execute it, making a function call so that our application can execute this function. So it has sent back the appropriate function and the arguments or the parameters back to the application. Now application uses this information, so application executes. So here where the application gets executed, and the result is stored in the function response, and this function response is sent again to the LLM. If you see, it is again sent to the LLM. So in this case, here in this case, the model decided which function to call, and it does the function calling. Our application executes that function based on the parameter and the function which has been sent by the LLM, and It returns the response which the function got to the model formats and sends it to the user. This is what happens here itself. See the application LLM. So the function execution result is sent back to the LLM. Now if I execute this program, still processing, so you can see that it has executed the get weather function. So this is the process. But then if it can execute like this, then what is the need for MCP? If you see, there are some function schemas which you need to send along with the user query. Okay, this needs to be sent so that LLM knows which tool to be executed, and this needs to be sent again and again because LLM is stateless, means once the transaction is complete or once the flow is complete, it does not remember anything. So we have to send this schema again and again. Okay, so for example, tomorrow you want to build three applications, say one for energy related application, one for agriculture related application. Like for example, crop management, you want to see what the weather is before uh, have a plan for the crop, and then you want to have a utilities in energy in the grid management, where you want to see based on the weather when the consumption of demand increases. Then in other application transport management, you want to see when it is raining or when the temperature is will not be good, so that the transport can be managed better. So for that, whenever you want to have a different type of application, each time you have to define these functions. So if you have three applications and there are two functions, so 3 into 2, 6 times. So this needs to be written 6 times for each of the applications. Tomorrow, if you want to extend this to 5 applications or 10 applications, 10 into 2, it is 20 times. So you have to rewrite this code. There is no reusability. And then you have to rewrite this function schema into all the applications. It's a lot of code. And whenever the user asks us different types of questions, then this schema needs to be sent again and again. So this is the M into N. So for each application, you will have to write all the functions which are needed. So you need to copy paste, or yeah, you need to write these functions again. Now next we will see with the introduction of MCP how this gets resolved. Now that we have seen how a typical application interface with the LLM and how the function has function definition and then the function schema which will be sent along with the user query so that LLM understands what are the tools available. Then I just want to show you how the MCP server looks like when the same code is moved to MCP server. We only have only two, just basically this much of code, only the tool definition. There is no schema. If you see in this application, there is a lot of redundant code is available. Here only the definition is only the tool definition. But this is a MCP server. So when we use a MCP client, when and then the client automatically gives a handshake to the MCP server, looks for the tool and automatically generates the functional schema. But before I explain the steps, I first want to show you how it works. So I'll first open the Claude here, go to the developer settings, go to the developer. Here I have already added so Claude acts as a MCP client, okay? And then if I edit annotation where the MCP server is hello world, and I have also given the path this hello MCP server is located, so that it does the functional calling and goes to this MCP server and then also passes the function and the parameter to execute it. Okay, so this hello world, if you see here, Here you see the hello world is enabled, and this MCP server has two function definitions: get weather and get quality, as you can see over here. Not this one. As you can see, it is actually exposing this function definition: get weather and get air quality. Now if I ask what is the weather in Paris, now this will go and fetch the tool hello the get weather. See, I'm passing this city Paris. The clock asks me whether ask my permission to execute that function. So I click on allow once, and then it makes a function call and then goes to the function gets executed, and it sends back that response. So here actually it sees the weather in the Paris right now is sunny, 19 degrees. So this is a mock-up data which I'll show here. See the temperature, it says 15, 17 kilometer. It's just giving a random number. So even the temperature is random number between 15 and 30. So it has picked up 19. So this is coming from, so this function returns it. So the MCP client makes a handshake, gets a schema, and then it passes that function schema automatically along with the user. So you don't have to provide it, but the MCP client generates it. And similarly, if you ask one more question, the same question again, let's ask this, or maybe the air quality. What is the air quality in Paris? Let's see. Again, it makes a function call. The cloud kind makes a function call because it has identified there is a relevant function available. And I click on once, and this time it executes that this air quality get air quality function, and again it's a random number. It randomly gives you that this answer, and that result this function result is sent back to the LLM, and then LLM formats it and sends it in a way. So the process of typical application to LLM, and then the with usage of MCP server and MCP client is the same, but using MCP server and MCP client resolves that M into N problem. So you don't have to have each port for each cable, like you saw in the in the first picture when I showed you each port. For HDMI you have a separate port, for USB you had a separate port. So that problem is resolved because now you have a client. The client automatically makes a first handshake to the MCP server, gets all the schema, and then based on the user query, it sends the along with that it will send the functional schema. And there is another one where you can also disable or enable the function. So this also gives you additional control, so that the token usage will be minimal, because when you send the function schema and the user query, the token limit extends. We will get to that in our MCP security, but for just for you to understand this one, so you have a greater control on which tools to be enabled. So what we have seen is the local MCP server, which means this MCP server is inside your laptop or inside your inside your system. So it is locally created. That's why it's called local server. But we also have certain global servers. Maybe I can quickly show you that. Mm, See, there are also a web-based global MCP servers where you can easily connect, and they would actually expose a lot of tools. Like for example, if you go to Figma has exposed few tools, like for example design context, screenshot, metadata, where you can use these tools to execute it internally in the MCP client. MCP client meaning it could be Cloud Desktop is one of the client, Cursor is one of the client. Likewise, you have many other clients where you can build your own MCP client and then access this MCP server like Figma. And then if you go to GoDaddy, you have two tools: the check domain and suggest domain. So check domain, I think when you give a URL, it will check whether that domain already exists or not. So that is something you can actually check inside the MCP client itself. For example, in the Cloud client, if I connect it, you can actually check it inside the Cloud client itself. So there are some desktop extensions you have. Okay. Mm, okay. Now I'll give you a detailed explanation of how this works. Maybe we'll go to the slide. Now, when the user makes that same query, what is the weather in Paris? The application receives this input, recognizes it needs help from an AI or LLM. So it forwards the request to what we call it as MCP client. And yeah, think of it as MCP client as a smart middleman. It knows how to talk to about the application and then to the AI. The MCP client now has the user question, but before sending it to AI, it does something important. It gathers information about what tools are available, and these tools are hosted on something called MCP server. So MCP client tells the AI, hey, here are the functions you use. In our case, one of those functions is get weather, a tool that can fetch the real-time weather data. The AI knows its option. So what I meant is the MCP before sends the user query, it connects to the MCP server and it looks for all the tools which are available. It automatically generates that schema. The schema is already defined, the endpoints are already defined, everything is in the ready state. So it gets back the schema. Now MCP client along with the user query now sends the schema as well to the LLM. So if you see, it declares available functions to the LLM and then it sends it to the uh, sends it to the LLM. Then LLM, what it does, it understands the query. Then, based on the function schema, selects the appropriate tool, and then extracts the city from the question, and then makes a function call. Now, yeah, in fact, it sends back to the MCP client doing the function call. It receives the function call, executes this function, executes in the function in the sense it actually calls the MCP server, and then it MCP server executes the function, and the response is again sent back to the MCP client. MCP client receives the data, and then again it sends to the LLM for the formatting. Once the format is done, this is sent to the user. Yeah, it's sent to the basically it sends to the application, and application displays the result to the user. So this is what the MCP client and the server is, where the client takes all the heavy loading, reduces the load from the application, where it automatically generates a schema, automatically handles all the function calling, executes the function. Everything is handled seamlessly in MCP client. Advantages are, it says, accelerating the development and fostering a reusable ecosystem. So what does it mean? So MCP lets you build integration once and share them everywhere. If someone creates a Slack connector, any MCP compatible agent can use it instantly. So it's like a NPM for AI tools. No more reinventing the wheel for every project. Dynamically enhancing the agent capabilities and autonomy. So need your AI to do something new, just plug in another MCP server. No redeployment is required. Your agent discovers the new tools automatically. Architecture flexibility and future proofing. So MCP works with any model: Claude, Gemini, GPT, Llama, and build your integration once and swap model anytime. No vendor locking and no rebuilding when you want to switch. Now let's also focus some of the disadvantages. It's quite important to also understand this. Under the performance and scalability bottlenecks, the context window blot. which is a very important concept to know. So the challenge is every MCP tool description and response eats your context window. Let's say you have to connect to 20 tools that could consume 10,000 tokens just describing what's available. Yeah, and before your user even asks a question with a 100k context window, that's 10% gone immediately. So in a complex workflows with multiple tool calls, you can burn through context fast, leaving less room for actual conversation history and reasoning. So the tool selection becomes critical. Stateful protocol challenges. So MCP uses persistent connections, which sounds great until you need to scale. Each user each user session maintains its own connection state. So at 10,000 concurrent users, you are managing 10,000 stateful connections per server. So compare that to a stateless REST API where any server can handle any request. So horizontal scaling becomes tricky, and you need sticky sessions or sophisticated state synchronization. So for high traffic enterprise app, this architecture requires careful planning. Degraded reasoning quality. What does this mean is, when an AI has too many tools available, its decision making quality can actually drop. So the research shows that beyond about 10 to 15 tool, the model starts making worse choices about which tool to use. It's like decision fatigue for AI. So if you connect 50 MCP servers, your agent might pick the wrong tool or hallucinate capabilities. So yeah, and with regards to enterprise readiness, does MCP can really be used in the enterprise organizations? Like some of the disadvantages are authentication and authorization. Here, the enterprise deal breaker for many. MCP does not have built-in authorization standards, so each server implements its own authentication, creating a fragmented security landscape. Imagine auditing 30 different MCP server, each with different OAuth flows for API key methods. So there is no native support for enterprise SSO or token managements. So teams can end up building custom auth layers, which defeats the reusable ecosystem promise and creates a security review headaches. Lack of native observability. So when something goes wrong in production, and it will definitely, you need visibility. MCP does not include standardized logging metrics or tracing. So if a tool call fails at 3 a.m., uh, yeah, good luck figuring out whether it's a MCP server or a network or underlying API, uh, or the AI reasoning. The teams have to bolt on custom observability often inconsistently. So, for regulated industries requiring audit trails, there is a significant gap that needs third party solutions. Identity management ambiguity. Basically, uh, who actually who actually making the API call, the user, the AI, or your application? So MCP blurs these lines. So when your agent access a customer's Google Drive through MCP, whose credentials should it use? How do you audit? And what AI access versus what the human requested? This identity ambiguity creates compliance nightmares for SOC2 or HIPAA or GDPR. You need clear answers about delegation, consent, and accountability that MCP doesn't natively provide. So these are the basic disadvantages